Welcome back. In this video, we're going to be covering EBS encryption, something that's really important for the real world and for most AWS exams. Now, EBS volumes, as you know by now, are block storage devices presented over the network. These volumes are stored in a resilient, highly available way inside an availability zone, but at an infrastructure level, they're stored on one or more physical storage devices. By default, no encryption is applied, so the data is persisted to disk exactly as the operating system writes it. If you write a cat picture to a drive or a mount point inside your instance, the plain text of that cat picture is written to one or more raw disks. Now, this obviously adds risk and a potential physical attack vector for your business operations, and EBS encryption helps to mitigate this risk. EBS encryption provides at-rest encryption for volumes and for snapshots, so let's take a look at how it works architecturally. EBS encryption isn't all that complex an architecture when you understand KMS, which we've already covered. Without encryption, the architecture looks at a basic level like this. So we have an EC2 host running in a specific availability zone, and running on this host is an EC2 instance using an EBS volume for its boot volume. And without any encryption, the instance generates data, and this is stored on the volume in its plain text form. So if you're storing any cat or chicken pictures on drives or mount points inside your EC2 instance, then by default, that plain text is stored at rest on the EBS volumes. Now, when you create an encrypted EBS volume initially, EBS uses KMS and a KMS key, which can either be the EBS default AWS managed key, so this will be called AWS/service name, in this case EBS, or it can be a customer managed KMS key that you create and manage. That key is used by EBS when an encrypted volume is created. Specifically, it's used to generate an encrypted data encryption key known as a DEK, and this occurs with the generate data key without plaintext API call. So you just get the encrypted data encryption key, and this is stored with the volume on the raw storage. It can only be decrypted using KMS and assuming that the entity doing so has permissions to decrypt the data encryption key using the corresponding KMS key. Remember, initially, a volume is empty. It's just an allocation of space, so there's nothing yet to encrypt. When the volume is first used, either mounted on an EC2 instance by you or when an instance is launched, then EBS asks KMS to decrypt the data encryption key that's used just for this one volume, and that key is loaded into the memory of the EC2 host which will be using it. The key is only ever held in this decrypted form in memory on the EC2 host which is using the volume currently. So the key is used by the host to encrypt and decrypt data between an instance and the EBS volume, specifically the raw storage that the EBS volume is stored on. This means the data stored onto the raw storage used by the volume is ciphertext. It's encrypted at rest. Data only exists in an unencrypted form inside the memory of the EC2 host. What's stored on the raw storage is the ciphertext version, the encrypted version of whatever data is written by the instance operating system. Now, when the EC2 instance moves from this host to another, the decrypted key is discarded, leaving only the encrypted version with the disk. For that instance to use the volume again, the encrypted data encryption key needs to be decrypted and loaded into another EC2 host. If a snapshot is made of an encrypted volume, the same data encryption key is used for that snapshot, meaning the snapshot is also encrypted. Any volumes created from that snapshot are themselves also encrypted using the same data encryption key, and so they're also encrypted. Now, that's really all there is to the architecture. It doesn't cost anything to use, so it's one of those things which you should really use by default. Now I've covered the architecture in a little detail and now want to step through some really important summary points which will help you within the exam. Now the exam tends to ask some pretty curveball questions around encryption, so I'm going to try and give you some hints on how to interpret and answer those. AWS accounts can be configured to encrypt EBS volumes by default. You can set the default KMS key to use for this encryption, or you can choose a KMS key to use manually each and every time. The KMS key isn't used to directly encrypt or decrypt volumes, instead it's used to generate a per volume, unique data encryption key. Now if you do make snapshots or create new volumes from those snapshots, then the same data encryption key is used, but for every single time you create a brand new volume from scratch, it uses a unique data encryption key. So just to re-stress this, because it's really important, that data encryption key is used for that one volume, and any snapshots you take from that volume which are encrypted, and any future volumes created from that snapshot. So that's really important to understand. I'm going to stress it again. I know you're getting tired of me saying this. Every time you create an EBS volume from scratch, it uses a unique data encryption key. If you create another volume from scratch, it uses a different data encryption key. But if you take a snapshot of an existing encrypted volume, it uses the same data encryption key, and if you create any further EBS volumes from that snapshot, it also uses the same data encryption key. Now there's no way to remove the encryption from a volume or a snapshot. Once it's encrypted, it's encrypted. There are ways that you can manually work around this by cloning the actual data from inside an operating system to an unencrypted volume, but this isn't something that's offered from the AWS console, the CLI, or the APIs. Remember, inside an operating system, it just sees plain text, and so this is the only way that you have access to the plain text data and can clone it to another unencrypted volume. And that's another really important point to understand. The OS itself isn't aware of any encryption. To the operating system, it just sees plain text because the encryption is happening between the EC2 host and the volume. It's encrypted using AES 256, so between the EC2 host and the EBS system itself. If you face any situations where you need the operating system to encrypt things, that's something that you'll need to configure on the operating system itself. If you need to hold the keys, if you need the operating system to hold the keys rather than EC2, EBS and KMS, then you need to configure volume encryption within the operating system itself. This is commonly called software disk encryption, and this just means that the operating system does the encryption and stores the keys. Now you can use software disk encryption within the operating system and EBS encryption at the same time. This doesn't really make sense for most use cases, but it can be done. EBS encryption is really efficient though. You don't need to worry about keys, it doesn't cost anything, and there's no performance loss for using it. Now that is everything I wanted to cover in this video, so thanks for watching. Go ahead and complete the video, and when you're ready, I look forward to you joining me in the next.